Okay, let's look at some chain rule. Chain rule here. We've got to take the derivative of this radical function, so y prime would equal 1/2 times the function inside, 14x minus x to the 5th, all to the now negative 1/2 power. We just took the 1/2 power and knocked it down by 1, get us to negative 1/2, times the derivative of that inside function would be 14 minus 5x to the 4th. Let's go ahead and write that now as an answer. Y prime is equal to, I've got 14 minus 5x to the 4th in the numerator. I've got 2 root 14 minus x to the 5th in the denominator. And that's it. Okay, number 2, same thing. We're going to take the derivative. So y prime is equal to 1/2 times the function inside, 3 plus sine 8x to the negative 1/2, and then times the derivative of the function inside, which would be cosine. The derivative of 3 is 0, so that's just cosine. Times the derivative of this little function here would be 8. Don't miss that. We've got another nesting of a function there inside. So we've got a function and a function and a function. Equals, let's see, let's do a little reduction right here. Half of 8 is just 4, so that would be a 4. And we'll go ahead and write things in the numerator are 4 cosine 8x. Things in the denominator is just the square root of 3 plus sine 8x. And we're good right there. Okay, number 3, we're going to find the derivative by implicit differentiation. So we'll go ahead and take the derivative here. The derivative of 9y squared is 18y, but we need to multiply by the chain on the y. Y is some function of x. Plus the derivative of 5x squared is 10x. The derivative of the negative 7 is 0, and the derivative of 0 is 0. To solve this, or to find that derivative, I actually need to isolate y prime. Let's go ahead and subtract the 10x from both sides and divide by the 18y. And then go ahead and, so we got the 18y. We're going to reduce the 10 and the 18. That gives us negative 5x over 9y. We're good there. Okay, number 4, a little more difficult because they asked for the first and the second derivatives here. So let's go ahead and find that first derivative. The derivative of 2y implicitly would be 2y prime minus the derivative of x would be 1 plus this we have to be careful. We've got a product there, so we've got x times the derivative of y plus the derivative of x, which is 1 times y, equals the derivative of 5 is just 0. If I want to solve for this, I have to isolate the y prime again. So let's go ahead and just get the non-y prime stuff off of this side. So I've got x y prime on this side. I've got a positive 2y prime on this side. If I add the 1 and subtract the y, I can get 1 minus y on the right. And then, let's see, we'll factor out the y prime. Get an x plus 2. That equals 1 minus y over, actually, I'm not ready to do that step yet. 1 minus y. Got the x plus 2. Let's go ahead and divide both sides by x plus 2. 1 minus y over x plus 2. So there's my first derivative. I'm going to go ahead and copy that up here. So when I make room, I'll be able to refer to that when I do my second derivative. So first derivative is right there. Now we're going to go ahead and make some space here and find that second derivative. All right, so second derivative is just the derivative of the first derivative, so that looks like we need a quotient rule here, so we'll keep the denominator and square it. And then we'll keep the denominator, multiply by the derivative of the numerator, which is negative y prime, minus, keep the numerator this time, multiply by the derivative of that denominator, which is 1. This negative, I'm going to go ahead and let the negative pass all the way to the front. So it's the opposite of x plus 2 times y prime instead of the negative 1 being here. Let's just let it pass all the way through. That way when I do the substitution for the y prime, it's a little easier to do here. So I've got the opposite of x plus 2 times y prime, which is 1 minus y, we just found this a little bit ago, over x plus 2. Let's see, minus 1 plus y. Notice what happens here. This is kind of nice for this problem. The x plus 2's reduce out, and I'm getting close to being done here. X plus 2 quantity squared stays the same on the denominator. In the numerator I have a negative 1 and another negative 1, that's negative 2. I have a negative y, that's positive y, plus another positive y, that's 2y. So if we want, we can just stop right here. We could also factor out the 2 on the numerator and write that in factored form. But either way, we've got a first and a second derivative. All right, number 5. We've got water falling on the surface, wetting a circular area that's expanding at a rate of 2 square millimeters per second. We're asked how fast is the radius of the wetted area expanding when the radius is 155 millimeters. We want to round our answer to 4 decimal places. So let's see, they just told us the rate at which the area is changing is 2 square millimeters per second. And they asked us how fast is the radius changing at the instant that r, the radius, is equal to 157 millimeters. We need some function that relates area and radius. Well, most of us will say that the area of a circle is pi r squared. That's a great place to start. Let's go ahead and take the derivative of both sides. The derivative of a is dA dt. That's good because we have a value for that. The derivative of pi r squared is 2 pi r dr dt. And that's good because we're interested in dr dt. So let's replace what we can. dA dt is 2 equals 2 pi times r at that instant is 157, and dr dt is what we're trying to solve for. If we can go a little bit here, we can say that dr dt would equal 2 divided by 2, which is 1, also divided by pi times 157. If we put this in a calculator, we get approximately 0.0020 millimeters per second. So that's our solution. 0.0020 millimeters per second. Doesn't seem very fast, but it kind of makes sense. Number 6, we've got a ladder slipping down a wall. The ladder is 13 feet long. The top is slipping at a constant rate at 5 feet per second. The question is, how fast is the bottom of the ladder moving along the ground when it's 5 feet from the wall? So let's see what we've got here. We've got a wall, the ground, our 13-foot ladder. We know that we'll call this distance y, this distance x. We're going to assume that the wall and the ground are perpendicular. We're told that dy dt, the distance that the ladder is up the wall, is decreasing, so that's negative, at a rate of 5 feet per second. And we're asked to find dx dt, how fast is the bottom moving away from the wall here. How fast is that when x is 5? Well, if we remember our right triangle trigonometry, when this is 5 and that's 13, y will also be 12. So let's make a note of that y is also 12 at that instant. We need some formula or function that relates x and y for this situation. Well, we've got a right triangle, so Pythagoras ought to get the job done. X squared plus would equal 13 squared. If we derive everything here, we've got 2x dx dt plus 2y dy dt would equal the derivative of 13 squared, which is just 0. We can divide both sides by 2. That essentially just takes the 2's out of the equation here. We can solve for dx dt. Dx dt is going to equal the opposite of y dy dt divided by x. Let's go ahead and substitute values in here. The instant in time we're looking at, y is 12, dy dt is negative 5, and x is 5. So it looks like I've got 60 over 5, or 12 feet per second is how fast that ladder is moving away from the wall. And we've got that one done too. Number 7 says all the numbers whose sum is 240, we need to find the two that have a maximum product. And then they really give us a lot of help here. They says maximize q equals xy where x plus y equals 240. Well, if x plus y equals 240, then y equals 240 minus x. So q would equal x times 240 minus x, which is the same thing as 240x minus x squared. If I'm looking for a maximum or minimum, I'm looking for a first derivative of 0. So I'm going to take a derivative of q here and get 240 minus 2x. This derivative would equal 0 when x is equal to 120. Let's take a look at the second derivative.
Fifth grade.
Derivative would be negative 2 is all we would get for the second derivative, which is always negative, which means that this function is concave down, which implies that we're going to see a maximum at any critical points. The only critical point we have is 120. So one of the numbers is 120, and 240 minus 120 is also 120, so the other number is 120. So the maximum product comes from when both numbers are 120, and we have the mathematics to support that solution. Number 8, of all the numbers whose difference is 4, find the two that have a minimum product. So if x minus y equals 4, we want the product of x times y to be a minimum. So let's see. Y would equal x minus 4 in this case, so my product is x times x minus 4, or my product is x squared minus 4x. If we look at the first derivative here, we get 2x minus 4. That equals 0 when x equals 2. If we look at the second derivative, we get 2, which is always positive, which says we're concave up, which implies a minimum. And we're trying to find a minimum product. So at any critical point, we're going to see a minimum. Our only critical point is 2. So x is 2, and y is 2 minus 4 or negative 2. So this happens that 2 and negative 2 are the two numbers that would give me that minimum product. That's it. Number 9, we're given a velocity of a particle, t squared minus 3t plus 9, and we're asked to find the time at which the velocity is a minimum. So let's go ahead and find the derivative, try to minimize this function. So we get 2t minus 3. This only equals 0 when t is equal to 3/2. If we look at the second derivative here, v double, there is 2, which is positive, so we're always concave up, which implies a minimum at any critical point. The only critical point we have is 3/2. So therefore, the time that this thing has a minimum velocity is at 1.5 seconds. And that's all we need for that one. Our last problem here is just a Newton's methods problem. If you don't understand Newton's method, you need to stop in and see me, because it's something that's easier to show you with a calculator in hand here and you and I in the same room. But your solutions for this should be 0.13511270, and the other one is 1.8111020. So those two solutions. Again, if you're having trouble with this, get in and see me or check with me during class. And that's it.